This is video 6, and we're going to be talking about real-world problems, fractions, and decimals. I'm on page 35 in your packet. Notice here that it says bonus. You have a couple days to try this problem. You can ask people for help if you want. Read it carefully. Try to answer all of the parts. This will be bonus for the upcoming quiz. So give it your best shot. You got a couple days. I'll collect this page on Friday. Video 6 now moves on to page 36. Real-world problems, fractions, and decimals. So word problems that have to do with fractions and decimals. Rosie buys 2 24/100 pounds of sliced ham to make sandwiches. She uses 16/100 of a pound for a sandwich. How many sandwiches can Rosie make? Well, you could bar model this if you wanted to, and you have your whole bar, which represents the whole amount of sliced ham that she starts with. And you know, if you were going to bar model it, it could look something like this. This is the 2 24/100 pounds, and she's going to divide it into 16/100. You know, and there's some 16/100 here. So how many of those 16/100 can you get? How many sandwiches can you make with those 16/100? This is what the bar model would look like. So you would go ahead and say, oh, 2 24/100 equals 16/100 times how many units? They call them units. Each one of these little dividing up into pieces is called a unit. So to do that, you could multiply both sides of the equation by 100 to clear that decimal if you don't want to deal with the decimals, right? And it would move this over, and you get 224 equals 16 times what? Well, dividing by 16 on both sides, you would get 14 equals one of those units. You may or may not be able to follow that or understand that. You can also find this in your 6th grade textbook. Or you would do what we've been doing in class and take 2 24/100 and divide it by 16/100. And yes, we have to make our divisor a whole number and move our dividend to the same number of decimal places. Put our decimal point up into our quotient. And I know 16 goes into 22 once. I'm doing the traditional algorithm. When I subtract, I get 6, bring down the 4, and 16 goes into 64 4 times, and I get a remainder of 0. So Rosie, here's my Sable, Rosie, might as well use her name. Rosie can make 14 sandwiches. And I could take out my calculator because I definitely want to be sure this is correct. And I would put into my calculator 14 times 16/100, enter. Oh, it is 2 24/100. So Rosie can make 14 sandwiches. You want to check to make sure your answer is correct as you were or before you are writing your Sable. So that's question number 3. Number 5. A paper artist uses 18 paper rectangles for a collage. He uses 6 of them for the border of the artwork. He then cuts the remaining paper rectangles into equal strips of 1/4 of the paper rectangle. How many strips of paper does he cut? So if he's using 6 of them and he starts off with 18, I know 18 take away 6 would give me 12. So I have 12 paper rectangles. Again, I could bar model this or not. But I'm going to show it to you as a bar model. We're going to be doing this unit next, bar modeling. And I'm taking those 12 and I'm cutting them into quarters. And this is hard to write on here, but you get the idea. How many quarters could I cut this into? How many? So how many strips are there? And in a model, you should always have a question. So what's the question here? Is how many strips will it take if I take 12 and divide it into quarters? Well, 12 equals quarters times how many units? Well, then I would divide by 1/4 on both sides, but we don't divide by fractions, right? We don't do this. So we multiply by the multiplicative inverse. So the multiplicative inverse of 1/4 is 4. Multiplying by 4 on both sides, I get a cancel. I get 48 equals the units, 1 unit. So he must cut it into 48 strips of paper. Otherwise, I would take 12 and divide it by 1/4 if I'm not doing the bar model, which we know is 12 times keep it, change it, flip it, multiplied by the multiplicative inverse, which is 48. So and again, to check this, I would do 48 times 1/4, the multiply problem that goes along with this. 48 times 1/4 would give you 12. And you could take out your calculator and practice. Oh, there's the bell. He cuts 48 strips of paper. There's my sable. Number 7, Andrea buys 75 cups of cranberry apple juice for a party. She uses 2/5 of the juice to make punch. She then uses the remaining juice to pour single servings that are 5-6 cups each. How many single servings does Andrea pour? Okay, again, I'm going to bar model this, and it's fifths. So I'm going to divide my bars best I can into 5 equal pieces. Oh, pretty close. There are 75 cups total. So the whole thing is the 75 cups. And I'm dividing it into fifths. She uses 2/5, so that's this part. That is the punch from here to here, which means these are the single servings, which is left, the 3/5. So 1 take away that 2/5 gives me 3/5 to use for the single servings. But the 3/5 times 75, right? 3/5 times 75. So I have 3/5 times 75. And I know that 5 goes into 75 15 times. So there must be 45 cups remaining. So 3/5 of 75 are the single servings part of this. So there must have been 45 cups that remained. That's one way, the bar model way that I could do it. Or I could take 45 and divide it by 5/6. Now we're dividing that 45 into 5/6 of a cup each. Well, that's 45 times 6/5, and we're going to cross cancel that, and we get 54. So Andrea pours 54 single servings. Page 37. Meredith bakes 5 pumpkin pies. She cuts the pies into quarters and distributes the pieces equally among her neighbors. Each neighbor receives 3/4 of a pie. Well, we could draw 5 pies and divide that up into 3/4 pieces. But I'm not going to bar model this one. I just know that I have 5 whole pies. Each person gets 3/4. So how many neighbors is she going to be able to give that to? How many neighbors does Meredith distribute the pies to? So I'm going to change this to keep it, change it, flip it. And 3 doesn't go into 5, so nothing cross cancels here. And I get 20/3. Well, I can't leave it like that. I have to simplify that to 6 2/3. Well, you can't have 2/3 of a neighbor, right? So this answer, interesting answer, the most she can distribute to is 6 whole neighbors, right? So Meredith distributes to 6 of her neighbors. She just happens to have 2/3 of a pie left over for herself, maybe, right? So when you divided this, you get a mixed number. Why is this mixed number not the answer to the number of neighbors? Because you can't have 2/3 of a neighbor. Biotic or biological living things, we don't round up because she doesn't have enough for 7. We only take the whole number part of it. So biotic things you never round up. Meredith distributes to 6 of her neighbors. So sometimes in the real world, our answers don't really make sense. That 2/3 doesn't make sense here. She just keeps that part. Good for her. What fraction of the pie is left? Well, if she has 6 neighbors that she distributes 3/4 of a pie to, right? We have to figure this out. So I can cross cancel 2's out of there, and I get 9/2, which is the same thing as 4.5. So 5 pies to start with, and she's given 4.5 pies away. So she has she has 6 2/3 neighbors, but that's not 2/3 of a pie. And I might have said that incorrectly before. She has a half of a pie left, right? 5 minus 4.5, she has a half of a pie left that she can keep. So half of a pie is left. That's neighbors, that 2/3. So I may have said that incorrectly. What is the total amount of pie each neighbor will receive if the remainder is divided evenly and distributed to each neighbor? Well, if she has 5 pies divided by 6 neighbors, they each get 5 divided by 6, which is 5/6, right? Each neighbor could get 5/6 of a pie if she has nothing left over, if it's divided evenly. But remember, she had a half of a pie left. But if she gave the 5 pies to each of her 6 neighbors, they would get 5/6. But she didn't. She gave 6 neighbors. She had that 2/3 of a neighbor left over, which really was half of a pie. So each neighbor could get, if we did it evenly, each neighbor could get. So interesting problem, different ways to ask the questions about dividing up the pie. Could get 5/6 of a pie. They didn't, though. They got 3/4, right? So cool way to show that division problem a couple different ways, just if you slant the question a little bit. So that's it for today's video.